This is a timer system from a previous video where I took a look at this box of junk that I had collected off of Facebook Marketplace through a friend. But this is some type of countdown timer, and I want to tear it apart today, and I want to see how hackable it is. So first off, let me kind of explain how this works. This has a plug on the back of it. You'd plug this into the wall. You would plug a load on the other side of the outlet here, and you set your time. You can set 15, 30, 60, or 120 minutes. I think they add together the more of these switches you have up. And then you have a start and a reset switch for the timer, and then you can just manually turn on and off the outlet here. So this has some kind of a relay in it to turn the power on and off from the input to the output. And this is it works in the opposite way that I would expect it to, because when you set your time and you say start, it actually keeps the load off until the timer runs out, and then it turns the load on, instead of running the load for a certain amount of time and then turning off. So it's inverted to what I would kind of expect an electronic timer to be, and maybe there's some use for that. But anyway, you can see it's a Micronta electronic countdown timer. It says made for RadioShack on the back of the bigger brick here. If you read it, made in Hong Kong. Not sure how old it is, but it's old enough to have rust on the screws. So let's go ahead and just take a screwdriver to this thing and see what we can find. Another interesting thing I've noticed is that this brick, the actual power supply and switching part of it, seems to have a capacitor or something across the relay that switches the power on and off. Because if you hook up an LED to it, LED bulb, it kind of remains like half lit, whether or not the thing is trying to turn it on or not. There we go. It's just got plastic clips on the top, which kind of felt like they broke, but it's okay. We're not going to use it again. Some interesting looking circuit board traces, maybe not quite hand drawn, but like this area especially is very interesting looking. You wouldn't see that on something today. There's a part number on there. No indication of a date as far as I'm seeing. Like I said, the sort of end goal of this is to rip this out and then have this replaced by an Arduino, essentially. So this is interesting. There are actually two boards down in this. That front board has all the switches on it and the LEDs for the user interface. Guess we're going to have to pop that out too. Kind of would have expected it to all be on one board, but it does look like the board that I do have pulled out so far is fairly well populated. Let's see, it's going to be a little bit difficult to get in here. Not really sure how they manufactured this thing, because it doesn't look like there's like a ribbon cable in there, but I don't think it has connectors on it. It looks like it's just soldered in solid, so I'm not sure how they cut this together with any kind of volume or efficiency in manufacturing. But anyway, I guess that wasn't too hard to get out. You can see the back of this board has some very beefy solder joints on it for the switches in the front. You know, 3 switches, 3 LEDs, and then might be a capacitor. It also kind of looks like a NTC or something, which is interesting, but I'd guess capacitor. And then look at this. We have a, at the center of everything, everyone's favorite timer chip. A good old 555. You can do anything with the 555 timer if you try hard enough, I suppose. Let's see what the rest of this stuff is. Kind of assuming basic sort of logic chips. That's an MC14020B. And there's a 14001B. And a 14516B on the bottom here. I'm not entirely sure what those are, but I'd imagine they're relatively simple chips. Nothing too special, probably some type of logic thing. I'll have to look up the data sheet and see what all those things are, but yeah, we're based around a 555 timer, which is kind of cool. We do have a variable resistor up here, which I'm not sure if that was accessible through the case anywhere or not. I don't think it was. That must somehow adjust the timing in order to make these switches more accurate with the 15, 30 minutes and all that kind of stuff. There are kind of a lot of jumper wires going around on this board. I don't think those are necessarily bodge wires because it looks like they had places for them and everything, but it's likely an artifact of this being a single-sided board. They just had to have a lot of jumpers. But anyway, one thing that does look promising is that there are 3 wires in this control scheme here coming up through this cable, which I would assume are a power ground and then a relay control signal. So let's go ahead and pull this apart. And really what I want to see in here is I want to make sure that this isn't being powered by like a capacitive dropper or something like that. Because if it is, that's going to be a little bit more dangerous to play around with than something that's powered off of, say, a little transformer. And I'm kind of expecting to find like a small transformer type power supply in here because this does have quite a bit of weight to it. It almost feels like a like old school transformer based plug pack like this. But we'll whip the screws out of here, see what we find. Probably won't be super interesting, but we'll see. Oh yeah, there's a little transformer in there. Fairly simple. Actually pretty thick wire going down the inside of this too. It is, I forgot to mention, it is rated fairly high in terms of electrical load. You can see, let's see, where's it at? 1,000 watt resistive load, a 1/4 horsepower motor, or a 350 watt incandescent lamp. So rated for fairly beefy loads, all things considered. So anyway, in here we have a small transformer, which is good, kind of what I was expecting. And then we have a fairly large ceramic fuse in there, which is nice, and a 12-volt relay for the actual power switching. So presumably this circuit runs at roughly 12 volts. And then this board looks pretty simple. We just have a capacitor there and 4 diodes forming a bridge rectifier to rectify the output of this little transformer, which will no doubt power this circuit. Though that kind of does make me wonder what inside of this was making the LED that I had hooked up to it glow so brightly. Potentially it's just capacitive coupling from the wiring somewhere in here, but I'm not sure. Let's see if we can break this board out and get a closer look at it. I'm sure there's not going to be much to it though. So there's a screw underneath the fuse. Pop that guy out of here. It's actually a pretty nice looking fuse. It's like the type of fuse that you'd see inside of like a British plug almost. Usually appliances in America don't have fuses that are this large, and they're also usually glass. Not, at least it looks like it's ceramic. Feels like it's ceramic as well. Quite a bit of red, I assume that's like Loctite or something over the screws. It does kind of look like this board. There's this big brown spot here around the capacitor, which kind of makes me nervous that this cap may have leaked out. Well, would you look at that? That would explain why my LED continued glowing even while it was switched off. There is a capacitor soldered on the back of here, and it looks like that capacitor is soldered between the output of the fuse, and the input of the fuse is connected to the hot side of the plug here, and then the other side of that cap is hooked up to the hot side of the output plug. So that little guy right there would be the reason why my LED bulb kept glowing. Now, I am still kind of suspicious of the top side of this board because it definitely looks like that capacitor's seen some better days. if you look at it, the sort of shrink wrap around the cap is quite... Oh man, I can't focus that close. Focus this close, maybe. Hopefully you can kind of see this. I'm having a hard time focusing on things this close, but the capacitor, the shrink wrap around it is very, almost looks like it rusted underneath of it, and it's all wrinkly. It looks like it kind of leaked out all over this board, which is a little bit unfortunate. That is just a 25 volt. I'm not sure what value cap that is. 25 volt, 220 microfarad, it looks like. One on the back, the cap on the back here is actually branded Nichicon, which you've probably heard of if you know anything about capacitors. It is also kind of interesting that the one on the back is just sort of thrown on here, like a bodged on afterthought. So it is possible that this capacitor was just thrown on here potentially to prevent relay contact arcing or something like that. Maybe it was to prevent welding. Maybe it was some EMI thing. I'm not 100% sure what that would be doing back here, but I'm pretty sure that I could take it out and not affect the operation of the circuit. So I'll probably end up doing that, because if you try to power an LED through this, which I intend to power an LED bulb through this guy, that's going to cause issues because it's going to leave the LED on pretty much all the time. Because that capacitor might not pass much current, but it'll pass plenty enough to keep a couple watt LED lit. So I think if I actually want to use this, I'm going to have to replace this capacitor, and I'm going to have to take this capacitor in the back off. If anybody knows more about why you would want to have a capacitor between or across a relay contact like this, I would be curious to know, so let me know in the comments. But let me do some work on this guy, and we'll come back here and figure out how to trigger this thing using the wiring harness that's on it without needing this board. Alright, we're back with the modifications made. You can see this capacitor is not in very good shape at all. Look at the bottom of it, it's kind of melty. And it's got shmoo coming out the side, so that's never a good thing. But I put in a new capacitor. This one's 470 microfarads because that's the closest that I could get, unfortunately, to 220. Apparently I don't have any 220s laying around, but really shouldn't make that much of a difference. It'll just have a little bit of extra filtering, I suppose. And then I removed the capacitor off the back, which is marked as 0.047K, so probably like 4.7 microfarads, something like that. But anyway, I also cleaned the board up because there seemed to be, well, obviously there's that puddle of residue from the capacitor. I scraped that off the screwdriver, actually, because it's very caked on there. And this board is single-sided, so there's no real risk of damaging anything by scraping on it on the top. And then it also seemed like it had either maybe like mist that condensed from the capacitor onto everything, or flux residue or something, but I wiped that all off with alcohol, so it's much cleaner now than it was before. So all I should have to do is reinstall the fuse, put the screws back in this thing, and see if we can't get it to trigger just using the wires hanging off the end. I also desoldered this. I forget if I mentioned that or not already. So let's put our screws back in, and we'll see if we can't get the relay to trigger externally. Now, the one thing that is going to be slightly challenging maybe to drive this with an Arduino is that I noticed that that relay is a 12 volt relay, meaning that I'm going to have to send 12 volts into this thing in order to trigger it. So you wouldn't be able to run it directly off of, say, a 5 volt logic level output of your Arduino, but obviously it can be done through a transistor. I was also looking at the other circuit board here, and the date codes on these chips look to be from, what was it, 1983 or 4? Yeah, what I'm assuming are date codes. 1982, 43rd week of 1982, I believe, is what that means on that chip. So, pretty old. Early 80s electronics that we're dealing with here, or at least those chips from the early 80s. And then on the other end of this wire, which comes out of here, of course, we should have plus 12 volts ground and then a relay control signal, which is either going to activate the relay by connecting to ground or to 12 volts. So we'll see. There should not be any kind of 120 volt high voltage. There should not be any kind of like 120 volts or anything like that getting back across these lines. So there shouldn't be any danger in leaving these exposed, minus shorting it out and potentially overheating the transformer in this thing, because there's not really any protection against that. And we'll bring a multimeter in just to check voltages, make sure I'm correct and I'm not about to completely shock myself here. I know this is kind of a mess already just from this little tiny bit of work I've done on it. But let's grab a wire. Okay, so we're putting about 22.5 volts DC out of these two wires, which I guess kind of makes sense. It's probably like a 12 volt transformer, and then you're rectifying that. And it's also an unregulated power supply that's entirely unloaded right now. So my question is, if we start tapping this white wire, ooh, look at that. White wire to ground, my lamp turns on. There we go. And you can hear the relay click too, probably. Hopefully you can hear that anyway. And just out of curiosity, let's see what kind of current we're pulling. There we go. Relay takes about 50 or so milliamps to activate, it looks like. And as one more test, let's just see what the voltage of the power supply dips to while the relay is on. This is going to read as negative, but it's still about 16.7 volts actually. Alright. I'm sure me bumping the relay contacts repeatedly like that is very not good for the relay, but it seems to be holding up even without that extra capacitor across it. So anyway, that should work fairly well. If I wanted to power an Arduino off these red and black wires, which is kind of the end goal, I'm probably going to have to use a switching regulator to buck this voltage down to 5 volts, because 22.5 is pretty high to be feeding into the regulator of an Arduino. And then it should be pretty easy to use an in-channel MOSFET to turn on and off the actual relay. So it should actually be pretty easy to hack this thing into an Arduino controllable outlet. But that'll kind of make a good reuse project for this little guy. So you'll probably be seeing it again in the future here eventually. Hopefully you guys found that little teardown and hack/repair interesting. I'll see you in the next video, guys. Bye.